Can young blood really slow down aging? What sounds like a myth from vampire stories is actually being studied in modern laboratories, and the results are astonishing. Experiments with mice have shown that when older animals receive plasma from young mice, their memory improves, muscles grow stronger, and even organ regeneration is boosted. Scientists have identified specific proteins in young blood that seem to play a crucial role in these effects. And it doesn't stop with animals. In the United States, startups like Ambrosia have already tested so-called youth plasma transfusions in humans. Some participants reported feeling more energetic and mentally sharper, but critics warn that the science is still uncertain and the risks could be serious. The idea that a simple blood transfusion might slow aging sounds like the ultimate anti-aging therapy. But what's really behind these experiments? Are we witnessing a genuine medical breakthrough, or just dangerous wishful thinking? In this video, we'll explore the science behind youth plasma, examine what has actually been proven, look at the risks and controversies, and ask if the secret to longer life might already be flowing in our veins. Aging is not one single process but the result of many biological changes. Every time our cells divide, the telomeres at the ends of our chromosomes shorten. Eventually, they become too short, and the cells stop dividing, a state called cellular senescence. At the same time, damaged proteins and DNA errors accumulate, slowing down the body's ability to repair itself. Organs become less efficient, muscles weaken, and the immune system loses strength. Another key factor: the chemical signals in our blood. In youth, blood is full of growth factors and proteins that support regeneration. As we age, these decline, while inflammatory signals rise, pushing the body further into deterioration. In short, aging is driven by cells losing function, organs breaking down, and blood chemistry shifting in ways that reduce repair and regeneration. And this is exactly why researchers are so fascinated by young blood. If plasma contains factors that keep tissues young, could transfusions really delay aging? The first hints came from groundbreaking experiments with mice. In the early 2000s, scientists revived a classic technique called parabiosis, surgically connecting the circulatory systems of a young mouse and an old mouse. The results shocked the scientific world. The older animals began to show signs of rejuvenation, faster muscle recovery, better memory, and even improved heart function. Meanwhile, the young mice aged more quickly, suggesting their youthful factors were being drained. Researchers then focused on identifying the molecules responsible. One protein in particular, GDF11, seemed to play a key role. When old mice were given GDF11, their muscle and heart performance improved. Further experiments with plasma transfusions showed similar effects. Older mice regained cognitive abilities and even grew new brain cells. These results ignited a wave of research. If something as simple as young plasma could rejuvenate mice, could it also work in humans? That question led to controversial human trials. The most famous human trial was launched by the California startup Ambrosia. Participants, mostly wealthy older adults, paid thousands of dollars to receive plasma from young donors. Some reported improved energy, better sleep, and sharper thinking. Blood tests even hinted at metabolic improvements. But scientifically, the evidence was weak. There were no control groups, and placebo effects could not be ruled out. The U.S. Food and Drug Administration, FDA, quickly warned against such treatments, calling them unproven and potentially unsafe. Risks include immune reactions, infections, and the unknown long-term consequences of repeated transfusions. Still, the idea attracted enormous attention, especially in Silicon Valley, where billionaires are investing heavily in anti-aging research. For some, young plasma became the ultimate luxury treatment. Meanwhile, universities began studying the question more rigorously, focusing not on transfusions themselves but on isolating the key proteins in young blood that might one day be turned into safe, effective drugs. If proven effective, young plasma could transform medicine. One area of hope is neurodegenerative disease. In animal studies, plasma from young donors improved memory and stimulated the growth of new neurons. Applied to humans, it could one day slow or treat conditions like Alzheimer's and Parkinson's. Another possibility is heart and muscle health. Proteins like GDF11 appear to boost cardiovascular function and muscle regeneration, potentially countering age-related weakness. Plasma could also improve healing after surgery or injury, giving older patients the ability to recover more quickly. And then there's the most ambitious vision, anti-aging as prevention. Instead of waiting to treat age-related diseases, medicine could intervene earlier, slowing down the aging process itself and keeping people healthy for longer. This could extend not just life expectancy, but more importantly, health span, the years of life spent free from disease. But such hopes must be balanced with caution, because for every exciting potential, there are equally serious risks and ethical dilemmas. Blood transfusions are never risk-free. Even under strict medical standards, they can trigger dangerous immune responses or infections. With young plasma, the long-term risks remain unknown. There is also the problem of exploitation. Some clinics charge thousands of dollars for treatments without solid evidence. Critics warn that this could create a black market for young blood, turning it into a commodity for the rich. The ethical concerns run deeper. Would it be acceptable for young people to donate plasma primarily so that the wealthy can try to buy more years of youth? Would this create a society where aging itself becomes a privilege of the rich? There's also the issue of scientific responsibility. Overhyping plasma research risks undermining public trust if the results don't hold up, or worse, if harmful side effects emerge. In short, between hope and hype lies a wide gap. Young blood might represent a breakthrough, or just an expensive illusion. The question is, what comes next? Most scientists believe the future of anti-aging won't rely on transfusions. Instead, research is moving toward identifying and replicating the youth factors in plasma. If proteins like GDF11 can be isolated and manufactured, they could become drugs or injections that deliver the benefits of young blood without the risks. Biotech companies are already racing to develop such therapies. Some are testing protein cocktails to rejuvenate tissues, while others use artificial intelligence to search massive blood databases for hidden anti-aging signatures. The vision is clear. Instead of transfusing plasma, we may one day have safe, targeted treatments that slow aging at the molecular level. But the question remains, even if we can slow or stop aging, should we? A world where people live decades longer raises massive social, economic, and ethical questions. What's certain is that blood as a fountain of youth may only be the beginning. Humanity's search for eternal youth has entered the laboratory, and it may transform our future in ways we can hardly imagine today. The idea of young blood as a fountain of youth has captivated humanity for centuries. Now, for the first time, science is testing it seriously. We've seen that animal studies show remarkable rejuvenation effects. Early human experiments sparked both excitement and controversy. The potential is enormous, slowing diseases, boosting recovery, even delaying the biological clock. But so are the risks, medical dangers, commercial exploitation, and deep ethical concerns. The most promising path likely lies in identifying the key molecules in young blood and turning them into safe, widely available medicines. Whether that will truly deliver longer, healthier lives remains to be seen. The big question is not just can we slow aging, but should we? What would it mean for society, for fairness, and for the human experience if we really unlocked the secret of eternal youth? Now it's your turn. Do you believe science will one day slow or even stop aging, or will time always remain undefeated?